All right, welcome to day one of the Barnabas Robot Arm class. So here we go, Robot Arm. Now, as we get started, I want to first talk about what we're going to go over in this course. So the first thing that we're going to do is we're going to build robots. Now that's not surprising. This is a robotics class after all, and if we weren't building robots, it wouldn't be a robot class. Now what does that actually mean? Well, to build robots, you need four different things. Number one, you need EE, or electrical engineering. Draw a little lightning bolt for electricity. So every robot needs electricity in order to work, in order to turn on. And so as electrical engineers, we have to learn how to use electricity to power our robot. So we're going to learn about that. Another thing that we need to learn about is ME, or we call it mechanical engineering. And usually, this is drawing some gears here. Okay, mechanical engineers, they work on the body of the robot. They look at motors, they look at gears, they look at the external stuff like the enclosure of it. So another way to think of it is if you look at a car, and if you're looking at a Tesla car, electrical engineer would work on the battery of the Tesla car because it's an electric car, and the mechanical engineer would work on the wheels and the external part. We call it the chassis or the external body of the car. Okay. Another important part is CE, computer engineering. I'm going to draw a little cube or rectangular box like this. So back in the day when computers were really big and not in the palm of your hands, they came in these big towers, they would call them. And so that's what represents my computer. So computer is the brain of the robot. It helps the robot make decisions. And without the brain, your robot can't function. It can't make decisions. So we're going to learn about computers as well. And then lastly, SE, software engineering. And what that is, that's the part where you tell the robot what to do. So there has to be something that goes into the computer. So the software actually goes into the computer. See, one way you can think about it is that the computer is kind of like your iPhone or your Samsung phone. Now, your iPhone or Samsung phone, it can't really do anything on its own if it didn't have anything, no apps installed on it. It needs some kind of software or an app for it to actually do anything useful. So the software engineer is someone who works on things like video games or websites, stuff like that. So we're going to learn about software engineering as well. So all of these things together need to come together in order for you to build a robot. So we're going to learn about all four of these things. So that's cool. Now the other thing that we're going to learn about, which I think is just as important, is this. Career skills. So what are career skills? Well, career skills are these are skills that you need to succeed in life outside of the classroom. So we can learn how to do EE, ME, CE, and SE here, okay? But if we can't use these skills outside the classroom, if we can't actually use them at a job, then it can only take us so far. So my hope is that in this class, not only would you learn these things, you would also learn how to apply them in a possible future career. Now, you may be thinking, well, I don't want to be a robotics engineer, and I don't want to be an engineer at all, so why do I even care about this part 2 of the class? Well, here's what I would submit to you. Even if you're not looking to be an engineer as a part of your career, there are still career skills that you will learn in building robots and in this class that you can apply to any career. Okay, and if you don't trust me, I'm gonna write a little bit more here. I have 3 main things that I want to teach you throughout this course, in the area of career skills. Number one, I'm going to teach you how to fix things. So as we build robots, and as we learn about these things and see how they come together, they're going to break all the time. And sometimes it won't work the first time. And you're going to need to learn how to fix it. So there's actually a process that you have to go through to become a really good fixer of things. And I'm going to teach you how to do that throughout the course. The better you are at fixing things, the better off you're going to be in this class. The better off you're going to be in your career, because what happens if you wanted to go into robotics as a career, your boss is going to throw something on your desk and say, hey, this robot doesn't work, can you fix it? And he's probably not going to give you any instructions, or he or she probably won't give you any instructions. So how are you going to do it? So we're actually going to practice that and learn how to do that effectively in class, because that's a real thing, knowing how to fix things. Okay. Another one is innovate. So innovate, what that actually means to innovate is to create something new to better mankind. So innovations are things like the light bulb. Thomas Edison created the light bulb. Not only was it really cool, it also changed our lives, right? Imagine a world without lights. Okay, another innovation could be the iPhone. So when I was growing up, there was no iPhone or there was no smartphone. So when that innovation came out, things like GPS, like through Google Maps, that became all of a sudden available in the palm of your hands at any time because of something like a cell phone or the smartphone or iPhone. You could do things like do emails or do Snapchat or whatever the new social media thing is these days. You could do all that in the palm of your hands because of this innovation of the smartphone. So we're going to actually learn, how do you innovate? How do you become someone who can actually create new things to change and better mankind? So we're going to use, not only will we learn these skills, we're going to learn how to apply them to make something new. And then the last one here is to share. Now, when you see share, I don't mean like we're just going to share our parts with each other, or sometimes, our parents might say, be nice and share your parts. So that is part of it. But what I also mean when I say share is being able to communicate, to take your ideas, the things that you've learned, and communicate them with others. So that's something that I've learned through my career, that if you can't share your ideas effectively, you're not going to get very far in your career. Okay, so those are the three things, and we're going to touch upon these things throughout the course. So it's not like we're just going to learn how to fix things on day one and then we're done forever. We're actually going to learn how to fix things throughout the course. So we're going to try it on this project or that project and a project down the road, because it needs practice. All these things need practice. It's not just like you learn it once and then you got it. Like I'm still learning how to do these things. And so these the career skills right here, little star here, career skills, we are going to learn these career skills through building the robot. Okay, so this class also is not just about learning career skills and then not doing anything else. This class is really about building the robot, and as we build it, we're going to learn some of these career skills. The last point that I wanted to that I touched upon was that I said, if you don't want to be an engineer, this can still apply to you. Well, let's look at this. Fix things. It doesn't matter what you do. If you're someone who can fix a problem, you're someone that is going to be valuable to any company or organization. It doesn't matter if you're a teacher, a nurse, a lawyer, a mechanic, right? Or whatever it may be, or a robotics engineer. If you're someone who can fix things, you're going to be successful in what you're doing. And you're going to be that person You want to be that person on in your team where it's like, oh, something's broken. Oh, that person can fix it. So as we learn about these career skills, and specifically fixing things in this class, that can apply to whatever you choose to do in the future. Innovate. To innovate is to create something new, right? So regardless of what you're doing, if you're a politician, right now it's the season of politics right now with the voting coming up. So if you're someone who's a politician and you see some problems in society, it's your job to create or to communicate your ideas of new laws, right? So a new law, maybe it hasn't been created before, but it's something that can better mankind. So you got to have some new ideas that come out. And so there's a process called innovation, or to learn to innovate, that will help you with that. Okay? So it can apply to anything. That's just one example. And then the last one, share. I kind of touched upon this with sharing ideas. It doesn't matter what you're doing. If you're someone who can share and communicate what is on your mind, that in a sense is also related to leadership. So any field that you go into, that field needs leaders. And the leaders are people who can communicate effectively, because if you communicate and you have good ideas, you can bring people together. Okay, so that's just one example, and we'll touch upon it more and more as the course develops, how fixing things, innovating, and sharing helps us not only in our STEM careers or our engineering careers, but also any career that we choose. All right, so without further ado, let's go ahead and get started on today's specific lesson. So I'm going to move this to the side here. Okay, so today we're going to learn about electrical engineering. And so I'm going to talk about this guy. This is a heart. Now the heart is what I like to call the battery. Okay, now all batteries have a plus and minus in it, and the reason I draw it like a heart, because the heart is represents the thing in our human body that gives us blood or power. Like without the heart, we can't function. So just like that, in a robot, the heart without a battery, it also can't function. All right, so here is the heart, or the battery for a robot. And what needs to happen is that electricity needs to come out of it. Okay? So what happens is that electricity will flow from the plus back to the minus. And you can see a loop here. So what this is called is actually called a circuit. Okay? Now the circuit has to do with this loop here going from plus to minus. Now there's a few different types of circuits. There is something that we call the closed circuit. Okay? The reason why it's closed is because there's a closed loop here. See, there's no gap. Now let me draw a second one. Draw it over here. Another circuit. So this is similar to this one right here, except there's an opening right here. So this one right here, this is actually called an open circuit. Okay? Open circuit, it's got an opening. Closed circuit, because there's no opening, it's all closed up. So the first question here is, which one of these is the one where electricity is actually flowing? Well, the answer to that is that it's the closed circuit. The closed circuit is the one where electricity flows, And the reason why is because there's a path from plus. It can go from plus all the way to minus. So electricity will then flow through. Now, the open circuit, electricity is going to try to come out like this, but it can't get through because there's this opening here. So because of that, there's actually going to be no flow. All right? So today I want you to remember, closed circuit, electricity flows. Open circuit, no flow. All right? Okay, so now let's go another level here. So going back to our circuit. There's our battery here. What if we create a circuit and then we add something to it? So what's going on here is that this is in the path of the closed circuit. So we've got a closed circuit here, but we put something in the way. So if you put something in the way, what happens is that as the electricity comes out, it goes through the item and then comes back. And it just keeps going and going. So if you just think about it a little bit, if electricity goes through something, that thing's going to turn on. Now this thing right here, this is an LED, also known as light emitting diode. Okay? So this is a light that is very efficient. One little tidbit about LEDs is that they save a lot more energy when compared to the regular incandescent lights. That's why you'll see a lot of houses, they're changing over to LED lights. Okay? So it's a very common part. It's used in a lot of electronics, and so we're going to actually try to build our first circuit by you putting a LED in the way of the heart. Okay, so what we're going to do is we're going to pull out this guy. Now this is a junction board, and you'll notice that these two black little plastic things right here, these are called headers. Okay, these two headers. So whenever I refer to headers, I'm talking about these two things. Now what headers are used for is that you're able to stick things into them and then make connections. So you see all these holes here? All these holes are for a metal connection. So you're able to stick things in there. So for example, here's like a wire and there's a metal tip right here. It would fit directly in there. So let's say if I wanted to connect something right there, I would just stick it in and it fits in there. So that's what headers are for. Now these two headers are special in that they fit this thing perfectly. Okay, so this is a Arduino Nano, and earlier I was talking about the brain. This will be the brain of your robot. But today we're not going to put any apps or software on it. We're just going to use it as a power source. So don't worry about all these crazy things on there right now. You know what this is. We'll get into that another day. For now, just know this is a brain, and we're going to use the power source that is actually a part of the brain. Okay, so now what we're going to do is we're going to stick this thing onto here. Now you got to do this carefully. When you stick it on, you don't want it offset like this. You see how this is offset? You want it to go on perfectly, and it should match pin to pin. Okay, see that? It should match. Now you could get it mixed up here. So what needs to happen? So what needs to happen is that this USB connector, the silver USB connector, needs to be facing this thing. Okay, what I mean by that. Let me clarify. If I go like this, see, I could still stick it in, but look, it's not facing that black part, okay? So that's important. Make sure you go like this. It's facing that way, so I got it kind of pushed in, and then now you just push, boom, and it's in there. And I can double check everything's lined up. Now, if you do it the other way, it's not going to ruin it. You just pull it out and put it in the right way, okay? All right, so we have that. Now let's take a look at this board, okay? You're gonna see here, different writing on here. So right here it says GND 3v3 and a bunch of different things, okay? So what we're gonna do today is we're gonna use 3v3. So I'm gonna update my schematic here. The plus is gonna be 3v3 and the minus is G and D. Okay, so a couple things here. The plus is always going to be the high number, or the power source. 3v3 that we see here on our brain here, it's the same as 3.3 volts. Now you might be wondering, what is 3.3 volts? I'll get into that in a second, okay? Now GND is always going to be connected to the minus here whenever we're doing circuits in this class. GND is the same as 0 volts. Okay, so now that we've established that, ground is the same as 0. The way that I like to remember it is that when you're standing on the ground, it's always beneath you. So it's kind of like wherever your feet are, that's where the 0 is. Okay, so we start at 0. And then the plus, well, right now it's 3.3V. The value of the plus will depend on how much power you're giving it. The V is a measure of power. So V is volts, and it's a measure of power. So 3.3 volts, that's a certain amount of power. You could also put 5 volts, but if it was 5 volts, you have a little bit more power. Now this LED right here, it needs 3 volts of power. So if we put like 1 V or 1 volt of power on the plus, this would not turn on, right? So 3.3 is a good number, and it's not too high. Like if it was 5V, 10V, it might overpower the LED, which is not good. But 3.3, that will work out, all right? Because it's above it, but not too much above it that it would hurt the LED. All right, so let's go ahead and try this. So I want you to grab one of these, okay? So this is an LED here. This is the little light, and then we have these two kind of like pin headers right here. So it's 2 pins, okay? Now as we look at this, there's one wire that's red and one wire that is black, okay? If you turn it one way, it's like that on both sides, okay? One is black, one is red. So how does that work? Well, the black is minus. So LED actually has a minus on it, and then the opposite of minus is plus. So the red is the plus, black is the minus. So we got to make sure we get this right, okay? So the plus of the LED connects to here, because that's that path, and the minus of the LED with the black one connects down there, okay? So now let's go ahead and try this. We need to connect this to here because we have GND and then we have 3V. See, now the issue, check this out. I have pins on this side and I also have pins on this side, so it doesn't match. So how are we going to do this? How are we going to do this? Well, let's look at what other tools we have. So this is part of, we're going to have to think a little bit. You know what? It doesn't go in. We can't quite get it. So this is what we're going to have to do. We have this guy right here. Okay, this is a breadboard. So next week, we're going to go deeper into what the breadboard is. For this week, this is all we need to know. Okay? The breadboard has, if we turn it this way, the breadboard has groups, all these rows. There's a row here, there's a row here, there's a row here. If you count it carefully, there are 17 rows. And your breadboard might be a different color. Either way is fine. So you might have a green one or a blue one. Mine is white. But if you count from here to down here, you have 17 different rows. Here's the thing about the breadboard, okay? Every group of 5 holes, like 1, 2, 3, 4, 5, these 5 holes, they are connected together. So what that means is if I put this into here, like the hole like this, and then I take like a yellow wire, and then I put it like there, because these 2 wires are in the same row, these 2 are connected. But if I go like this and move this down here, are the black wire and the yellow wire in the same row? No, they're not. So they're not connected anymore. Okay, but if I want to connect it again, I can put it up here. Those 2 are connected. All right, that's all we need to know today. Now you notice that there's 2 sides of this, right? There's this side on the left and there's this side on the right. I just ignore that for now. Like this side right here, we're just gonna not use that side, okay? Just ignore it. So only this side we're gonna worry about. So we're gonna use a breadboard, and then we're gonna use some socket to pin wires. So if you look in your kit, you're gonna see these guys. All right, now in the way you know it's a socket to pin is one side's a socket and the other side is a pin. All right, so you can go ahead and like peel these things peel like this, and let's get a gray one, and then let's get a red one. So another thing that I want to teach you guys, and I want you to hopefully get this, be consistent on this throughout the class. Red, we always want to use red for the plus, okay? That's because everyone in the world uses red as plus. So if someone's trying to look at your circuit to see what's wrong, or they're trying to learn from it, they're going to expect that red is plus. It's called a convention. So it kind of eases, makes things easier for other people to come in on your project, okay? So I want to learn some good habits here. The other one is that the minus is always something like gray or black, okay? If you have a black one in there, you can use black. Gray is close enough. So the minus is always going to be, that's why I'm using the gray. All right, so now let's connect the plus to the breadboard. So what we do is we find the plus is we're going to be connected to 3v3. So then we go here and then we plug it in. All right, and it goes right there. Now let's just stick it in the top row here. Boom. All right. So that means this entire top row is 3v3 now. And the next thing that I'm going to do is going to take the minus. So let's take the gray wire and connect it to G and D. There. Okay. So let me show you here just to be clear. And then let's put this on the second row. All right, and I'll give you a little look here. Now it's very important that these two, you see the red and the gray, they are not on the same row. They're on different rows, okay? because something else is supposed to make the connection between the gray and the red, which is this LED. So now we're going to take our LED right here, and if you remember, the black is the minus and the red is the plus. So let's go ahead and stick this in and make sure we match it up. So whatever we're building right here needs to match our drawing, okay? So if the black is minus, then that means the minus needs to connect to the minus of the battery, which is being created through the brain right here. So the minus needs to connect to the gray. So let's stick this in. And if you notice conveniently, if I go like this, it just automatically, the red one will go to the top row, which is correct too, because the red one is plus, and that's supposed to connect to the 3v3. All right. So let's just make sure everything's clear there. All right, so we got it connected. Why does it not work? Right? What are we missing? Well, I said that this is our brain, and it's going to help us create our battery, but we need to give it some external power. So the way that we do that is that we're going to connect something, our cable, to here, and then the other side will connect to your Chromebook. So this is what happens. You got to take your cable right here, and you're going to stick it in. Make sure it clicks in there. All right. And then this larger side, that's going to connect to your computer. So what's going to happen is that your computer is going to give you power, and it's going to go through this blue cable into the brain, and then the brain has some they have some circuits in there, and it does some stuff so that 3.3 V of power comes out on this red wire. Okay, so let's go ahead and do that. All right, so we're going to go ahead and do that, and if we do it correctly, our light right here should turn on. Here, let me get everything centered here, okay? So I'm going to plug it in, and there we go. All right, so my light is on. I have a red color. You actually have 3 of these LEDs in there. I'm going to give you a challenge to try it with, you can take this out here, and then try it with another LED, and then your job is to find out what are all the 3 different colors, because they should be different colors that you have there in your kit. Okay, so that's it for today. We learned about the overview of what the course is going to be, a little bit about circuits, about the brain, and then how to connect it up to get our light working. All right, have fun with that, and hope you figure out all the colors. Talk to you later.